Hi, welcome back. We're continuing to talk about graphing logarithms and transformations. In our last video, we looked at graphing a function that had an a and a k, but it did not have an h. In this video, we are going to look at a function that has an h value. So we are going to graph the function g of x is equal to 1/2 times log base 1/4 times x minus 3, or log base 1/4 of x minus 3. All right, so I'm going to start by identifying. A is 1/2. H is positive 3. Positive 3, this is shifted to the right because this is x minus h. And our k is 0. So this graph is going to be shifted to the right 3. And it's going to be vertically shrunk with no horizontal or with no vertical transformation. Our base is 1/4. And our input here is x minus 3. Our input is no longer just x. It is x minus 3. So this is what am I putting into my logarithmic function? And in this case, it's x minus 3. So my domain is that the input has to be positive. So x minus 3 is positive. X must be greater than 3. So that gives me a domain from 3 to positive infinity. That domain gives me my asymptote at x is equal to 3. So we have to graph that as a dashed line. And before we get into that too much, I want to think about what this transformation was. So when we have an h value of positive 3, this is a horizontal shift. So my vertical line here was shifted to the right. My whole graph, I took my graph and I moved it to the right 3 units. So the vertical asymptote should be at x equals 3. That makes sense. All right. So now I need to think about my convenient logs. So to do this, I'm thinking about my base of 1/4. So I am going to write I'm going to start with 3 exponential statements that give me 3 that are going to help me come up with 3 convenient logs. So 1/4 raised to the negative 1 is positive 4. 1/4 raised to the 0 is 1. And 1/4 raised to the 1 is 1/4. Turning each of these into a logarithmic statement. So log, the base is 1/4. This is my base. This is now the inside of the log. And this is now the other side. So this 4 here is my input, which is x minus 3. So my goal is what should x be to get x minus 4, or I'm sorry, to get x minus 3 equal to 4. So I'm now thinking x minus 3 is equal to 4, x is equal to 7. So I'm inputting 7. So if I put 7 in here, 7 minus 3 will give me 4. So this is going to give me 1/2 times log base 1/4 of 7 minus 3, which is 1/2 log base 1/4 of 4. And I know that this is negative 1. So I have 1/2 times negative 1, which gives me negative 1/2. Next, I'm going to look at this here. So I have 1/4 raised to the 0 equals 1. This becomes log base 1/4 of 1 is equal to 0. I want my input to be equal to 1. So I'm looking at x minus 3 is equal to 1. X should be equal to 4. So I'm going to plug 4 in for x. And if I do that, I get 1/2 log base 1/4 of 4 minus 3 gives me 1/2 log base 1/4 of 1, which I know is 0. So this is 1/2 times 0, which is 0. So I know I have the point 40. And now I'm going to work with this last one. This gives me log base 1/4 of 1/4 is equal to 0. 1/4 is my input, so x minus 3 is equal to 1/4. x is equal to 3.25. So if I plug in 3.25 for x, this should work out. So I've got 1/2 log base 1/4 of 3.25 minus 3 is 1/2 times log base 1/4 of 1/4, which I know that this is equal, that's not equal to 0. That should be equal to 1. So this is 1/2 times 1. This is 1/2. So now I'm going to graph these 3 points. So I have 7, 1, 2, 3, 4, 5, 6, 7, negative 1/2, 4, 1, 2, 3, 4, 0, and 3 1/4, 1/2. And my graph looks like that. So again, our process, we want to identify some key things. I would say that identifying your base and your input are going to be the most important. Your input is going to help you find your domain, which will then help you find your asymptote. Your base is going to be used to help you write 3 easy exponential functions to get 3 convenient logarithmic functions. We're then going to use our input with these logarithmic expressions to figure out what x should be. And then we're going to use these convenient logarithmic expressions to help solve for what y should be. And then we're going to graph it. My range here is going to be from -infinity to +infinity.